Welcome. I have this problem, 2 raised to the x plus 4 raised to the x equals 8 raised to the x. And I was given this problem by my friend Romeo Sadia and Henry Silva. And I wanted to know, can you solve? All right, so before I go ahead and show you step by step the way that I solve this problem, I want to see how you would approach the problem, and I'll start kind of brainstorming to get us started. You ready? Let's go. Okay, so this is kind of where I initially started getting into the problem, and I kind of got a little stuck. Now, the first thing I started looking at was, let's just try to see if there is a solution. So I took the regular equation and I said, all right, these are supposed to be equal to each other for some value of x, right? We're trying to find the values of x that make this equation true. And so what I did is I started just plugging in some numbers, some basic integers. I plugged in 0. 2 raised to 0 is 1. 4 raised to 0 is 1. And what I noticed was 1 plus 1 was which is 2, which is greater than 1. So I said, all right, so right now the left side of this equation is greater than the right side of the equation. Then I continued on to 1, and I got 6. 2 plus 4 is 6. Well, 6 is less than 8. So from the left side being greater now to the left side being less, I noticed that now there has to be a solution point. And that solution point then, x is going to be less than, or x is going to be greater than 1. I'm sorry, going to be 0. That's going to be 0 and 1. So I know this value of x that I'm going to be figuring out here is going to be between 0 and 1, because when it was at 0, the left side was greater, and then it was to the right side, it's now larger. And if I just kind of continue this pattern, once I got in this squared, this becomes 20 is less than 64. I start to realize that 8 to the power of x is growing much faster. I don't even need to get into cubes here and realize that 8 to the third power is going to go much faster than this. So I don't see there's ever going to be another intersection or another solution value where the left side is going to equal to the right side. The only time I can see that happening is between 0 and 1. So one thing I automatically notice here is each of these bases here, 2, 4, and 8, they can all be rewritten as a base 2. So I rewrote them as 2 to the x, 2 squared raised to the x, and 2 cubed raised to the x. And what that allows me to do then is to all write them with the base 2. And one of the important rules that we can use with logarithms, if I have a log base b of b to the x, that just equals x. So I wanted to take the log of base 2 to get rid of these x's in the numerator, or I'm sorry, as the power. Well, I could do that on the right side, but then I kind of fell short here on this left side because there's not a rule of logarithms when we have them separated by addition. If they were separated by like multiplication or subtraction, I could use the rules of logarithms there. So at this point, we kind of get stuck with the math because we're solving for x, but then x is also in the answer. So that doesn't really work. So what I did to go ahead and figure this out is use substitution. So let's go ahead and go back to this point. So therefore, I'll just kind of erase this. I already have my summary up there. So I can rewrite this as 2 to the x plus 2 power rules of exponents, that's 2 to the 2x, equals 2 to the 3x. Now, I can't just solve for x. So what I'm going to do is I'm going to get them all over to the same side and set it equal to 0. So 0 equals 2 to the 3x plus 2 to the 2x plus 2 to the x. OK, now I see that they all share a 2x in common. So I'll factor out a 2x. So by factoring out a 2x, I'm left with 2 to the 2x plus 2 to the x plus 1. And again, you might say, well, how exactly do it? Well, again, we can check multiplication. Remember the rules of properties of exponents. If I have x to the a x to the a times x to the b, that equals x to the a plus b. So x to the 2 to the x times 2 to the 2x equals 2 to the 3x. 2 to the x times 2 to the x equals 2 to the 2x. And 2x times 1 equals 2x. So now what I start looking at, though, is this starts to look like kind of looks like a quadratic, like a trinomial, but not with the bases. I don't want to try to solve this or factor. I'm sorry, I got those to the other side. These are both negative. Right? When you subtract those over, those are both going to be negative, so therefore these are negative. So now what I can do is I can look at this and say, well, that kind of looks like a quadratic. Let's go ahead and use substitution. Let's let u equal 2 to the x. So if I replace this whole equation with u, then I have u times u squared minus u minus 1. And this looks like a quadratic. Well, I can solve that. Now, I initially kind of looked into factoring, and there's no two numbers I can multiply to give me -1 that are going to add to give me a -1 here. So therefore, what I'm going to have to do now is use the quadratic formula. So again, instead of using x's here, we're using u. So I can say u is going to equal the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2a. And again, remember the a here is a is your coefficient of your quadratic term, b is the coefficient of your linear term, c is your constant. So now, by using my quadratic formula, I have u equals opposite of b, which is opposite of -1, which is 1, plus or minus the square root of -1 squared minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which again was 1. Okay, so now I'm going to go ahead and simplify this a little bit further down. So u equals 1 plus or minus the square root of 1 plus 4, because -4 times -1 is going to be a +4, all over 2. So u equals 1 plus or minus the square root of 5 divided by 2. Now again, we're looking for solutions here, right? And the main important thing is when we're looking for the solution is when we go back into our x squared, we can't have the negative go back into the logarithm, which I'll go and explain here in a second. But right now we have kind of like our two solutions. Now let's kind of go back into this 2 to the x world. If we kind of go back to replacing this u with 2 to the x, we have 2 to the x equals 0, right? Because u equals 2 to the x. Well, obviously that's never going to be true. If you know the graph of an exponential, we have a horizontal asymptote at 0. So that is not going to ever be true. So that's not going to provide us with a solution. If we're now going to say 2 to the x is equal to 1 plus the square root of 5, or you could say plus or minus square root of 5, divided by 2. Now, if I wanted to go ahead and solve here for x, I notice that I have the base 2, so I can go ahead and use my rules of logarithms, and I could take log base 2 of 2 to the x equals log base 2 of 1 plus or minus the square root of 5 divided by 2. Now, the reason why I can eliminate the negative is because when you're taking the logarithm, using at least real numbers, you can't take the logarithm of any negative number. So therefore, at least you're going to get a real solution. So therefore, I can eliminate this negative solution. And now, by using my rules of logarithms, log base 2 of 2 to the x is equal to x equals log base 2 of 1 plus square root of 5 divided by 2. So there you go, ladies and gentlemen. That is how you solve the equation. I hope you enjoyed, and I look forward to seeing you on the next example. Cheers.